Welcome to this new video on the square root of 2.
Is it the most important proportion in architecture?
The square root of 2 is an irrational number, infinite, that can also be understood as a ratio. It's approximately 1.41421356. And of course, when you square this number, you get 2. This irrational number was already known to the Babylonians, as proven by this tablet that's almost 4,000 years old. As we saw back in chapters 3 and 4, we can find its value thanks to the Pythagorean theorem, since the 1 square root of 2 triangle is, of course, a right triangle. From this, we deduce that the diagonal of a square with sides of length 1 equals the square root of 2. Now, notice this. The area of a square whose sides measure the square root of 2 is exactly 2. So, in order to double the area of a square, you simply multiply its sides by the square root of 2. But here's the question. What about the diagonal of that new square? I'll let you think about it for a moment. You can already guess it from the figure on the right. And yes, it's exactly 2.
This is exactly the same ratio we find in paper sheets of format A4, A3, and so on. An A0 sheet has a surface of 1 square meter, and its height equals its base multiplied by the square root of 2, that is 84.1 centimeters by 118.9 centimeters. An A4 sheet measures 21 by 29.7, and the ratio between its sides is the square root of 2. Notice that its diagonal equals 21 times the square root of 3. We'll come back to this in the next chapter. An A3 sheet is twice the size of an A4, and so how many A4s fit into one A0 sheet, in your opinion? Pause the video if you want to think about it. One A4 sheet is equal to 1 square meter divided by 16, which gives 0.0625. The proportion is preserved between the parts and between the sheets. 2 times the square root of 2 equals the square root of 8, that is 2.8284. In other words, exactly double the square root of 2.
Now, I'm going to share with you a simple little trick to draw the square root of a number. On a straight line, first mark 1, then 2, placed one after the other, which gives you 3. Then, using 2 arcs of a circle with the compass points set at both ends, you just draw the circle with a diameter of 3. From there, drop a perpendicular through 1. Where this line meets the circle, you get the square root of 2. It works the same way on the other side. Along a line of 1 plus 3, the vertical through 1 up to the circle gives you the square root of 3. Now here's the beautiful part. The ratio of growth between nested squares is always the square root of 2. The circumscribed circle of one square becomes the inscribed circle of the next, and vice versa. Each time, the surface area doubles, for the squares and for the circles as well. In many church and cathedral floor plans, the ratio between the sides of a single bay is about 1.4142. Pay close attention in your explorations. Sometimes you can even find this same ratio in the relationship between the width and the height of the entrance door of sacred buildings. Very often, the proportions of the doorway give us a clue about the proportions of the bays inside. For example, this is something worth checking in Saint-Philibert Abbey in Tournus, France, built in the Romanesque style. Later, in chapter 63, we'll see how the square root of 2 is hidden in the proportions of the octagon, and in chapter 108 in those of the heptagon.
Happy mathematical explorations. See you soon.
Thank you for watching this video.
Feel free to subscribe, like, and share.
See you soon for more discoveries on our channel. Sacred Geometry!